The agricultural revolution was essentially figuring out really good solar panels. You can kind of think about it this way. Crops are basically solar panels, and they absorb solar energy, they build it into a carbohydrate, right, which humans are able to consume and use for energy. And that really unlocked human flourishing, right? We had enough food to feed everybody, and we could then go about our days, a little bit more of our days, right? We were still working long hours to be able to eat, but we weren't spending all of our time just hunting and gathering.
Things changed dramatically once we were able to access hydrocarbons.
The equipment on farms that uses fossil fuels as its fuel so that you can go run a plow more efficiently. You're not using horses. You can use all sorts of processing equipment where you don't have to use human labor. So it's just amazing how it's just transformed all corners of our society.
The big thing happened when people realized that you could use the power of burning coal. Coal was a considerably denser and more efficient fuel to use.
You're no longer limited to the sunlight you could capture at that time. At that point, you're capturing sunlight stored for millions of years. That's when economic growth really took off, was when we were able to start accessing that level of energy density.
1 horsepower actually is a lot less energy or a lot less power than 1 horse can deliver. But James Watt invented steam engines, and he was selling steam engines, so he defined a horsepower to be equivalent to a very weak horse after a long week of work. As soon as we had steam engines, we could use steam power to industrialize the destruction of forests and to industrialize the extraction of coal, which could also be used to burn. So it's kind of this feedback process. Well, that feedback process, almost overnight, changed TFP growth, that is total factor productivity growth, changed GDP growth, and all these factors kind of fed into one another and created this kind of accelerating improvement in terms of just general quality of life.
People in the countries where the Industrial Revolution happened, income went up by a factor of 100. Lifetime expected at birth doubled.
A lot of human labor to more and more machine labor, because now you've got this fuel form that's easier to access, that's easier to transport. Some of these really early factories have like a giant motor that operates and turns like a huge gear, and there's a ton of like pulleys off of the system, and that machine will be doing whatever the human task was.
The founders were people who really thought toward the future. They thought, we want to build the foundations here for a country that can support, liberty and justice for everyone. And it's really important to remember that, like, in some ways, energy production is not super prestigious, but actually primary production is what made this country rich in the first place. And primary production is the thing that China is currently massively outcompeting the United States on. Primary production is the wellspring from which all our other forms of wealth grow.
To understand the possibilities of a hyperabundant energy future, we need to start in the past, because the past will show us how we got here and thus how we can get there.
The next really big aha moment was actually that there are big blocks of chemical energy underground. And it actually started out with peat, these composted chunks of biomass that slowly get turned into sort of a burnable form. And peat started getting burned in ovens, and it was used for cooking food, which actually helps that food to become more energy useful to humans as they consume it. We used it to start doing other things like making tools, and those tools can help us till the earth faster, those sorts of things. And then the next big one was coal.
Coal is a kind of rock. It's actually a form of solar power because it was laid down by ancient forests that spent many millions of years growing and then falling over. And so we just have these insane coal beds worldwide of like ancient forests that grew and fell over for millions of years. Today, as a result of like geological processes, it's essentially pure carbon, often with a little bit of sulfur or something mixed in. We can just dig it up and burn it. And digging up and crushing up soft rocks is about $10 a ton. So that's a pretty neat trick.
That really unlocked the steel age, and it unlocked transportation via trains and all these sorts of things that we didn't have access to before. And at each of those points, our standard of living just massively inflected.
I think it was in the 1700s roughly that basically extremely inefficient steam engines were used to pump water out of mines. So in Cornwall, which is the southern part of Britain, there are mines mostly for tin, which is used as an alloy of copper to make bronze. And there have been mines there going back thousands of years. We know that the Phoenicians, we know that the ancient Egyptians traded either directly or indirectly to get tin from southern Britain. And we also know that the Cornish miners were so expert at what they did that they became the diaspora all around the world in the 1800s that taught the rest of the world how to mine. So for example, California is full of all kinds of mines. Those mines were often founder staffed engineered by Cornish miners, the ones who'd survived, the ones who knew how to build stopes and blockade things and so on. And like they would dig these mines underground below the water table in southern Britain and then out under the ocean. So they're mining like up to a mile offshore through rock under the ocean. So these initial steam engines we used to pump water out of the mines. How does a steam engine work? Roughly, it's basically determined by how hot you can get the hot side and how cold you can get the cold side. And that the temperature spread is what allows you to extract mechanical energy. And for practical steam turbine stuff, it's in the 30s, maybe the 40%, low 40%, which is respectable. But easily 60 to 70% of the energy is going out as heat. Once had steam engines that could keep on feeding coal in. Basically, this kickstarted the Industrial Revolution.
Oil, black gold, I think really took humanity by storm. Like, this made the modern world. And I think to a degree that people don't appreciate. It's not just the fact that we have, diesel and gasoline to drive cars around. It also made the material reality of the world different. We have plastics and we have all of these, materials that we build the entire world out of. If you look around any room, I think most of what you're going to look at with your eyes is essentially built out of hydrocarbon.
Well, I'm just thinking about the chair I'm sitting on has some sort of plastic component in it. That's made from oil.
And the ability to actually have a liquid store of energy is very underappreciated, I think. The fact that you can hold energy in a bucket and you can take it from place to place is a massive unlock for humanity. That means that we can fly. It means we can drive long distances in a car that anybody can own. Anyone in the world can purchase a vehicle, even if it's just a small scooter, and they can get miles and miles where it would have taken, weeks before. Oil is one of the most interesting substances in the universe, actually. So if you look at the periodic table, I actually would challenge you to find a better substance than oil for just carrying energy around. And the reason for that is that it's oxidizable. So we have oxygen in the atmosphere, which means we have 1/2 of an oxidation reaction just waiting to happen. And then it turns out underground there's the other half, right, which is a hydrocarbon. And when you mix hydrogen and carbon with oxygen in combustion, you also get pretty clean elements as well. You get water and you get CO2, things that are already in the atmosphere. And that oxidation reaction, it turns out, carries an enormous amount of energy. You can put that through a pipeline. You can still put it on a train if you want to, but loading that into a pipeline and moving it across states with essentially no logistics at all, that's something that was only unlocked by oil.
And part of this history is that Standard Oil created the Industrial Revolution. Standard Oil, right, is this company which their mission statement is that they want to produce the highest quality oil at the lowest possible price to the customer. And so around the turn of the century, the company's formed and starts operating, and they start massively expanding. But as they're making profits, they take all the profits and put it into R&D, and they buy up these assets where somebody has drilled for oil. And if you drill for oil, you either get sour or sweet crude. Sweet crude is low sulfur, is ready to go right into a motor or engine or transmission, and it won't damage the metal. And a sour crude has high sulfur and basically can't be used, and no one knows how to use it. So they hire these scientists, run all these laboratory experiments, and they basically sit there and for years work on a solution. Meanwhile, the company just continues to buy up all the sour crude that no one else knows how to use. So it's pennies on the dollar. And they eventually just have this massive breakthrough and unlock it and go, well, we now have a chemical process. They basically developed one of the refinery processes.
America and oil have always gone together in a really special way because of the long fascination that America has had with moving things, right? We love things that move. We invented cars, right? And we wouldn't have been able to invent the car without something to put in its gas tank. We invented airplanes, and there's no formulation of an airplane that doesn't work without a hydrocarbon fuel. And these things are just stitched into the fabric of who we are as a nation. Having invented most of these modern forms of transportation that move us around the world, I mean, you can just see it everywhere in America. We love our cars, we love our airplanes. We have this lifelong obsession with them as a nation, and it's definitely stitched into our DNA.